In this video, we're going to continue the exploration of numerical variables. We're going to evaluate discrete variables, which are variables that take a finite number of values. So the variables are not continuous. They can only take a bunch of numbers. In a brute force approach to capture the discrete variables that works well for this particular dataset, we're going to loop over all the variables into numerical variables, and if the number of unique values is less than 20, so if we have less than 20 different numbers, then I'm going to assume that the variable is discrete. And of course, I'm going to exclude the year variables. We see that we have 13 discrete variables. Here we can plot some of them, and we see that the variable names are overall quality, overall condition, which refers to a scale that a person determines over the quality and condition of the house. This scale goes in general from 0 to 10. 10 is the best condition. And then it also refers to the number of bathrooms, or the number of half bathrooms, or the number of bedrooms and kitchens, and the number of total rooms, the number of fireplaces, garages, and so on. So that you can see that by definition the variables are indeed discrete. We can go ahead and plot the sale price for each one of these discrete variables. Note how we loop over the discrete variables, and we plot a box plot, which is this bit that we see here, and we overlay a strip plot, which is the dots that we see here. This allows us to see the evolution of the price. The line represents the median, and these are the interquartile range, so the interval within we find most of the information. And each dot represents one of the houses. So we can see straight away two things: the mean price for the category, but also if we have a lot of houses for that particular category, like we see here, or very few, like we see here. So we see that with the overall quality of the house, the sale price increases, which makes total sense. With the overall condition, it increases up to condition 5, but then it doesn't seem to increase further. With the number of bathrooms, it tends to increase if it has 0 or none, but then we have very few information to make any robust conclusion about a bigger number of bathrooms. And you can go ahead and explore the rest of the plots on your own and draw your own conclusions. We're going to move on to continuous variables, which we capture in a new variable here, and we're going to loop for each variable in the numerical variable list if the variable is not in the discrete or the years variable list. We can see some of the values here, and then to have a quick look at the distribution over the numerical variables, we just apply the histogram method from pandas, and we will obtain this plot with the distributions of all the variables. And we see that most variables tend to be skewed, like this one here or this one. Some are extremely skewed, most of the values are 0. So we capture the skewed variables here. I just take them from the plot. So I look at the plot here, and then, for example, Screen Porch and Miskval, they are super skewed, so I capture them in the list. And the rest I capture in this other list. And now, because most of the variables are skewed, I'm going to apply the Yeo-Johnson transformation to try and change the distributions into something that is more Gaussian looking. So I make a copy of the data because I don't want to override my original dataset, and then for each one of the continuous variables, using the stats module from SciPy, I apply the Yeo-Johnson on the variable. This returns two things: first, the transform variable, and then the Yeo-Johnson transformation parameter, so the exponent that we use in the Yeo-Johnson transformation to transform the variable. We repeat the exercise, so now we make a histogram over the transformed variables. And we see that for lot front age, the transformation didn't really do an amazing job, but for this variable that was originally skewed, now we have a more Gaussian looking variable. And the same can be true for variables like ground live area and this one over here. We can go ahead and plot now the sale price versus the original variable and the sale price versus the transformed variable, just to see if the transformation gives us an edge in the relationship between the two variables, because then we might profit from the variable transformation when we want to predict sale price. Here, for example, we have the original lot front age variable, and here we have the sale price. We can see that there is a better relationship here compared to after the transformation. But for the variable lot area, here the values tend to be accumulated towards the left, and here we see a better dispersion, so we might benefit from the transformation. Of course, we cannot conclude just from looking at the plots, we would have to do more analysis. For this other variable, we might benefit a bit from the transformation, and you can go ahead and examine the rest of the variables and draw your own conclusions. We're going to try instead the logarithmic transformation, and I will only apply it to these variables because the logarithm can only be applied to positive numbers and many of our variables have the value 0. So these are the only ones that we can transform. And if we plot a histogram of the transformed variable, we see that for all cases we have a more Gaussian looking distribution when we transform the variable with the logarithm. So we can go ahead and explore the relationship of the original or log transform variable with the target, and we can see that the relationship changes, but who knows if this is more predictive or not. For the rest of the course, we are going to transform this variable with the logarithm. We finally work with the skewed variables, and when the variables are very skewed, one thing that we can do is that if the variable has the value 0 in this case, which is the majority of the values, then we keep the 0, but any time that the variable has another value different from 0, we recode it to 1. And now we can group the sale price per these 0 or 1 values, and then we calculate the mean and the standard deviation. This is the same that we did with the missing values. And then we can determine if there is a change in the value, if the house presents the value 0 or 1. In this case, for the variable that we see here, we see that there is not a huge change. But for other variables like this one, there seems to be an increase in the sale price when the value is 0. You can go ahead and explore the rest of the variables in your own time.